Things like landslides, flash floods, and ground subsidence. These geological disasters feel like they're happening more and more, and they pose a huge threat to lives and our homes. We're all too used to reacting after the disaster strikes. But what if we could see them coming? Today, we're going to dive into an incredible early warning system that's all about turning prediction into real life-saving protection.
All right, so here's our game plan. First, we'll talk about the unseen threats lurking beneath the surface. Then we'll break down the warning system itself. After that, we'll get into the nitty-gritty of the sensing layer, the eyes and ears on the ground. Then we'll see how raw data gets turned into powerful intelligence. And finally, we'll see how it all comes together in a complete safety loop. So let's jump right in. So first things first, let's really set the stage. We're talking about incredibly powerful natural events, ground sinking, massive flows of debris, entire hillsides giving way. These are threats that can literally reshape the world around us in just a matter of moments. Now, the really scary part about these events is that they often seem to pop up out of nowhere. But here's the thing, that's not really true. The warning signs are almost always there. We're talking tiny shifts in the ground, water levels rising just a bit, or a really intense burst of rain. The real challenge, the real problem, is catching those super subtle clues in time. This is exactly why we need to make a huge shift from just reacting to actively predicting. And that is precisely where a comprehensive, fully integrated system comes into play. Look, this isn't about just one cool sensor or a single piece of software. It's a complete, end-to-end solution designed to give us that critical foresight we've been missing. The mission here is so much bigger than just monitoring. It's about analyzing what they call compound disasters. Figuring out exactly how heavy rain can trigger a landslide. The ultimate goal is to build this perfect, closed-loop safety process, from monitoring and analysis all the way to early warning, and this part is key, a guided, effective response. Okay, so now let's get down to the hardware, the real core of the system. Let's see how this thing actually gathers all its crucial data. The entire system is built on this foundation of super tough, incredibly precise sensors that act as its eyes and ears out in the field. So, at the very heart of this system are 3 types of specialized sensors, and you can think of each one as a critical piece of a puzzle, monitoring water levels, rainfall, and the tiniest movements in the ground. Let's take a look at each one. First up, we've got the radar level sensor. And this device is just brilliant in its simplicity. It gets installed way up above a river or a channel, and it uses radar to measure the water level without ever having to touch the water. What does that mean? Well, it means it can't get knocked around by debris or messed up by strong currents, which makes it incredibly reliable for watching out for flash floods. And just look at these specs. They tell you exactly why it's so dependable. It's accurate down to the millimeter. That IP68 rating, that means it's not just weatherproof. You could literally submerge this thing in water and it would keep on working. And that temperature range, wow, from -40 all the way up to 85 degrees Celsius. That means you can put it anywhere, from a frozen mountainside to a scorching hot riverbed, and you can absolutely count on it to send back that critical data. Next in our lineup is the tipping bucket rain gauge. Now, since heavy rain is so often the main trigger for both floods and landslides, measuring it accurately is completely non-negotiable. This thing is made of all stainless steel, so it's built for serious durability and, of course, precision. The key number to look at here is that 0.2 millimeter resolution. I mean, that level of precision lets the system tell the difference between a harmless little shower and the kind of intense, sustained downpour that totally soaks the ground, turning a stable hill into a ticking time bomb. So you see, it's not just measuring rain, it's measuring risk. And finally, the third piece of our sensor trio is the draw wire displacement sensor. This is the device that literally watches the ground itself. It's designed to pick up on even the tiniest shifts in mountainsides, slopes, or any area that might be prone to sinking. I mean, the specs on this are just incredible. It can measure movement up to 35 meters. That's huge. But the most important number on this slide is the repeatability, 0.05%. That insane level of precision is what lets it detect that almost invisible creep of a hillside. Those tiny shifts that can happen for days or even weeks before a total collapse. This is how you literally see a landslide coming in slow motion. So, okay, we have these amazing sensors out there collecting all this data on water, rain, and ground movement. But just gathering data, that's only the first step. Raw data is just numbers. So let's see how that information gets transmitted and then transformed into intelligence you can actually act on. This chart shows the journey perfectly. All that raw information from the sensors in the field gets beamed up, usually by satellite, to a central brain that lives in the cloud. That's where all the heavy lifting happens, the processing, the analysis. Then, the intelligence that comes out of that flows right back down to every level of disaster management, from the big national centers to the local first responders on the ground. And this is where the real magic happens. The cloud software lets authorities see a live, real-time picture of what's happening. They can set up custom alarms like, hey, text me if this river rises by 1 meter in the next hour. They can download historical data to spot dangerous trends, and it's all powered by a whole suite of different wireless technologies. All right, let's put it all together. Let's see how all these different pieces, the super tough sensors, the reliable data transmission, and the smart software, all click together to create a complete end-to-end safety loop. So, in a real-world situation, you're not just going to use one sensor. No way. You'd create a whole network of them. Picture these integrated stations all over a mountainside, monitoring rainfall, how wet the soil is, and ground movement at both the surface and deep underground. All this data works together to paint this high-resolution 3D picture of what's happening across an entire at-risk area. And this creates that beautiful, seamless 4-step process. First, the sensors are constantly monitoring 24/7. Second, the intelligent software crunches all that incoming data looking for dangerous patterns. Third, when a critical line is crossed, an automated early warning goes out. And fourth, the system gives clear, actionable guidance for disaster prevention and response. It's a full circle. Now, this is the really cool part. What makes this a true game changer? The system actually gets smarter over time. By building this massive database, it starts to learn the specific relationships for any given area. Like, it learns exactly how many millimeters of rain it takes to cause a certain amount of ground movement on one particular hill. And that makes all of its future predictions even more accurate. So, at the end of the day, the goal of this entire system is to fundamentally change our relationship with natural disasters. It's about moving away from that cycle of reactive recovery and shifting to proactive prevention. It's about getting those alerts out before a disaster happens so we can prevent casualties and protect property. This technology really gives us an